Hello friends, in our today's session we will discuss about elementary shapes, or in other words we can call it different geometrical shapes. Now, over the first setup, we have to understand what we mean by collinear or collinear points. So let's say that the points are said to be collinear if they fall in a single line. So let's say we have 3 points A, B and C. And if we can draw a straight line joining all these 3 points, then these 3 points are said to be in collinear. Similarly, if we look at the points P, Q, R, we cannot draw the straight line which is joining these 3 points. And so, this A, B, C are collinear points. However, P, Q, R are not at all collinear points. Now, moving ahead, something about the angles. So one turn of a particular straight line is called as complete angle. It is something like this way, and this angle measures around 360 degrees. Similarly, we have a half turn of a straight line. It's called a straight line or angle of 180 degrees. And the measure over here is again the 180 degree, that is half of 360 degree. Then we have a quarter turn as well, that is called as a right angle. It means if a line rotates up to the 90 degree, then this forms a right angle. Now angle between the 0 degree and 90 degree is called as acute angle. It looks like this way. So if you encounter figures like as shown in below, you can directly predict that these are nothing but just the acute angles. Then angle between 90 degree and 180 degree, these are called as obtuse angle. If you encounter figures like this, these are nothing but just the obtuse angles. In a similar way, the angle between 180 degree and 360 degree is called reflex angle, which is the complement or in fact supplement of the given obtuse angle, or in fact supplement of given acute angle, like this. It is something like this way. Okay, moving ahead, something about perpendicular. Straight lines are called perpendicular lines if they intersect each other at right angles. Let's say we have one perpendicular line of red and yellow in color. So you can say that this yellow line is making an angle of 90 degree with red line. And so this yellow line is basically the perpendicular to the given red line. In the similar manner, we have something called as perpendicular bisector. A line is called perpendicular bisector of a line segment if it bisects the line segment into two equal parts and it is perpendicular to the same. Let's say we have a line segment AB. As you can see here, that the line segment with the name as AB is of red color over here. And then we have a yellow line which is passing through this AB and intersecting this AB at point C. This is actually of 90 degree. This is making 90 degree with AB, and in such a way that AC is equal to BC. And so this yellow line is actually dividing AB into two equal parts, and also this is perpendicular to the AB. And so this yellow line is called as a perpendicular bisector. Similar way. Now let's talk about types of triangles. So we can define the types of triangles based on two different parameters. First based on sides and the second based on angles. So if we talk about the classification of triangle based on sides, so we have first type of triangle that is called as a scalene triangle. You can see here we have a triangle ABC. Herein side AB is not equal to BC and which is again not equal to CA. So that means all the sides are unequal, and so this kind of triangle is called as a scalene triangle. Similarly, we have isosceles triangles. Isosceles triangle means like if we have two sides of a triangle are equal, in that case, this kind of triangles are called as isosceles triangles. So we have a triangle ABC, out of which AB is equal to AC. That means two sides of the triangle are equal, and so the given triangle is called as isosceles triangle. Fine. In a similar manner, let's proceed further. We have equilateral triangle. So if all sides of the triangle are equal, in that case, the given triangle is termed as equilateral triangle. Okay, let's see the figure that is ABC. And under this figure, we have AB is equals to CA is equals to BC. That means all the sides are equal in length. And this kind of triangle is called as equilateral triangle. Now, in terms of angles, if we talk about, we have acute angled triangle. That means if all the three angles of a triangle are acute in nature, in that case the given triangle is termed as acute angled triangle. Similarly, right angled triangle. That means if one of the angle is 90 degree, in that case the given triangle is called as right angled triangle. In the similar way, obtuse angle triangle, like if one angle over here is an obtuse angle, then that kind of angle is termed as obtuse, and concerned triangle is called as obtuse angled triangle. You can see the figure over here, and we can find that angle ABC of this triangle ABC, this is an obtuse angle, and so the triangle ABC is a custodian of an obtuse angle, and that is why this is called as obtuse angled triangle. Fine. Now moving ahead, we have a few corollaries over there. Very important concepts. Let's discuss about all of them one by one. The first point is like if all angles in a triangle are equal, then its all sides are also equal. We can see here that if these sides are equal, so what kind of triangle will it be? Come on, the triangle will be equilateral triangle. Now all angles of a triangle are equal, right? So we know very well that or the sum of all the angles within the triangle is equal to 180 degree, right? So we have three equal angles. So one angle will comprise of 60 degree. So if we have an equilateral triangle, in that case all the angles of equilateral triangle are of 60 degree. Okay, just remember this point. Second point, if all sides of a triangle are equal, then its angles are also equal, which is just a converse of the above theorem. Next, if two angles of a triangle are equal, then it has two equal sides. I hope you remember about the isosceles triangles, right? It has two equal sides, and so it will have two equal angles also, right? Now, the converse of the theorem, like if two angles of a triangle are equal, then it has two equal sides, right? Then, if none of the angles of a triangle are equal, then none of the sides are equal, which is a pure example of a scalene triangle. Now, if none of the sides of a triangle are equal, then none of the angles are equal. Of course, yes. The same happens, that is the converse of a blue line theorem. Then we have, if one angle is 90 degree, then each of the other angle is acute angle. We have already discussed that the sum of three angles of a triangle is 180 degree, out of which one is 90 degree. Now we have left with two different angles. So that those set of angles cannot be greater than or even equal to 90 degree. Why? Because if you put it 90 degree, what should be the measure of the third one? Right? So that is the case. We need to make sure that if one angle of a triangle is 90 degree, the rest of the two will be acute angles. In a similar way, the sum of angles of a triangle is 180 degree. That's what we are discussing from the line number 1 over here. Then, at last, the sum of lengths of any two sides of a triangle is always and always greater than length of the third side. Okay? Just remember these corollaries. Now, let's move ahead. Types of quadrilaterals. First of all, we have something called a trapezium. Trapezium is nothing but just a quadrilateral in which one pair of opposite sides is always parallel. Like, let's say about the diagram, we have a quadrilateral ABCD, and you can see here that AB, AC, D, and out of this BC is parallel to AD, right? Similar way, we have something called as parallelogram, which is nothing but just a quadrilateral in which both pairs of opposite sides is parallel. And another important thing, like both pairs of angles are also equal and sides are also equal, right? So let's discuss this point. We have a parallelogram ABCD. So we can, at a diagram only, we can see that side AD is equal to side BC, and similarly side AB is equal to side CD. And in the same way, angle A is equal to angle C, which are opposite pairs, and angle B is equal to angle D, which are again the opposite pairs actually, right? Now we have rectangle. That is, if one angle of a parallelogram is 90 degree, then obviously all the angles will remain with the 90 degree. So that kind of parallelogram over here is called a rectangle. Then the diagonals of rectangle are always equal. So this is the figure how the rectangle looks like. We can see here that all the angles of this particular rectangle are 90 degree, right? In the similar manner, we have rhombus. That means if two adjacent sides of parallelogram are equal, in that case, whatever the figure we encounter, that will be of rhombus. So all sides of rhombus are equal, and diagonals here intersect each other at right angle. That means the diagonals always make an angle of 90 degree with each other. And this is the figure of a rhombus. This is how it actually looks like. That is A, B, C, and D. Okay. Then we have a types of quadrilateral. Another quadrilateral is a square. Like if two adjacent sides of rectangle are equal, in that case, what we get is a square. Here the diagonals are equal and they intersect each other at right angle. That means the angle between the diagonals is 90 degrees. And this is how your square actually looks like. Now, let's talk about the polygons. Here we have triangle and it has three sides, and so this is called as this triangle, and we can see that this triangle in in the figure shown here. Similarly, we have quadrilateral, that means something that has four sides. We have pentagon is something that has five sides. Hexagon is something that has six sides. Heptagon is something that has seven sides, octagon is something that has 8 sides. Okay, so these are the different polygons. Just look at the shape and remember them by the name. Tri, it means for 3. Quad, understand it as 4. Pent as in 5. Hex as in 6. Hept as in 7. And oct as in 8. Okay, then we have a very important concept of regular polygon. That means a polygon in which all sides have equal length and all angles have equal measure. That is called as a regular polygon. Okay, just remember the definition. Regular polygon is a polygon in which all sides have equal length and all angles have equal measure. Okay, now let's discuss about 3D shape, three-dimensional shape. First shape is of cuboid. Alright, you can see here a cuboid rotating over here. This cuboid has 6 faces, 12 edges. One edge is like one between two faces. Whatever the corner line we see, that is called as edges. And we have 8 vertices, that is 8 different corners we can encounter here. Then you can see here about the cube. You can see here that cube is, every face is getting pink over here at some moment of time. Here also we have 6 faces, 12 edges and 8 vertices, as we have already seen it in a cuboid. But actually cuboid is a 3-dimensional implementation of a rectangle and cube is a 3-dimensional realization of a square. Okay, then we have something called as prism. We can call it as a triangular prism as well. Again, this has 5 faces, 9 edges and 6 vertices. Prism you might have seen like in your physics classes also, through which you can turn your sunlight into 7 different colors. Then we have a square prism. It has 6 faces, 12 edges and 8 vertices. Now we have something called a square pyramid. This square pyramid is like at the base it is a square and all the lines meet at a single point outside the given square. That is called as your square pyramid. It has 5 faces, 8 edges and 5 vertices. Just remember the figure in your mind and you will be able to count that during your examination also. Then we have a special case that is called as tetrahedron. A special triangular pyramid where all the triangles are equilateral, and that kind of pyramid over here is called as tetrahedron. Now we have a sphere. You can see like we have a lot of examples to our daily life. We have a football which is a sphere, we have a cricket ball that is a sphere, our earth also a sphere, right? So that's all about the elementary shape. Thank you very much and have a nice time ahead. Bye bye.